I want to start by reviewing Lewis structures. There are 5 simple steps to drawing the correct Lewis structure. For the first step, all you have to do is find the total amount of the valence electrons for the molecule. For example, in CH4, we know that carbon has 4 valence electrons and hydrogen has 1 valence electron. But because there are 4 hydrogens, in this case we have to multiply that 1 by 4, which gives us a total of 8 valence electrons. In step 2, you want to place the least electronegative atom in the center of the other atoms. Note that fluorine and oxygen are very electronegative, so as you get further away from them on the periodic table, the atoms become less electronegative. The third step is placing the electrons between atoms to form a chemical bond. For example, putting the lone pair bond in between the carbon and the hydrogen. Step 4, you want to complete the octets on the outside atoms, and octet means 8, so there should be 8 electrons on the outside atoms. As you see here in carbon dioxide, each oxygen on the outside has 8 electrons, 4 counting the double bonds, and 2 lone pairs. In step 5, if the central atom does not have an octet filled, you want to move the electrons from the outer atoms to form double or triple bonds to the center atom. It's not all molecules will have to have this done, some will. Now I would like to talk about orbital hybridization. What it is basically a concept of mixing atomic orbitals into the new hybrid orbitals with different shapes and energies, etc. And you might wonder how you determine the hybridization. All you have to do is find a steric value of the central atom based on its Lewis structure. Here we have NH3. It has 3 single bonds and 1 lone pair. No matter if it's a lone pair of electrons or single, double, or even triple bonds, that each individually have a steric value of 1. So for example, NH3 has a total steric value of 4, since it has 3 single bonds and that 1 lone pair. So since the steric value is 4 for this molecule, it is sp3 hybridized. So to hit a little bit more on orbital hybridization, sp3 hybridized atoms have 109.5 degree bond angle, as seen below. And sp2 hybridized atoms have bond angles of 120 degrees, as you see there. sp hybridized atoms have bond angles that are in 180 degrees, which means they are linear, as you see there. The next topic I would like to talk about is resonance. When drawing Lewis structures, there are several known ways to place double bonds and lone pairs of electrons in the framework of atoms. The actual arrangement of electrons in a given molecule is an average of all the valid Lewis structures of that molecule. So the one that stands correct and actually exists in the real world is said to be the resonance hybrid for that molecule. Therefore, each Lewis structure contributes to the resonance hybrid is known as a resonance structure. And here we see below of benzene. Has all 3 double bonds distributed evenly around the ring. The furthest left is an example, and then the one to the right is the resonance structure of that first one. A double-headed arrow is used and placed in between the resonant structures to denote them from a derived structure. The curved arrow, however, is a formalism, a tool to keep track of movement of pairs of electrons during reactions. When using a curved arrow to show movement of a lone pair or bonded electron pair, you would draw the arrow going from the electrons and pointing to the atom that is receiving the electrons. The last topic today I would like to talk about is nomenclature, which is a systematic approach to naming chemical compounds. Here are the 3 principles to naming alkanes. I'll let you read for a few seconds. Here we have a 7-chain carbon molecule. We have a chlorine in the 2 position, a methyl group on the 3rd carbon, and a bromine on this next carbon. So therefore, the name of this molecule would be 6-bromo, 2-chloro, 3-methyl heptane. Heptane being the number of carbons in the link. Now let's talk about the nomenclature of the alkenes. Take a few seconds to read the rules. Here's the molecule 1-pentene. The ene suffix indicates that it is an alkene. It being on the 1 position is where you get the 1 to describe the position of the double bond. Here are the rules for naming alkynes. Take a few seconds to read, and then we will go on to an example. Here is an example of an alkyne. We have 5-methyl, 7-octane, 3-ol. So you want to start by numbering the longest carbon chain. So we have an alcohol group on carbon 3, and then the triple bond on carbon 7, and a methyl group on carbon 5. And you want to name the substituents in alphabetical order. So this the result in getting 5-methyl, 7-octane, 3-ol. Thank you. That is all I have for you.